All right, let's get started. Welcome to this session on 12 ways to make code suck less. So I want to talk about code quality, and I want to talk about why we want to improve, and then we'll talk about how to improve. So why should we really care about code quality? And the only thing I can think of really is we cannot be agile if our code sucks. As simple as that. You're sitting at your office, your customers, your colleagues, they're suggesting, oh, we should make this change to the software. In the back of your mind, you're thinking, wait, that change requires me to change this XYZ module. And the last time I touched the XYZ module, I could not go home for the weekend. I'm not going to accept this change, right? Now you're going to come up with excuses, reasons why we should probably not change this. Well, it turns out there is more to code quality than just writing code. In fact, this is a serious business. Why? Code is how you tell your colleagues how you feel about them. Do you love them? Or do you hate them? When you look at the code, that's when we know, right? So when you read the code your colleague has written, that's when you know what they really feel, how they feel about you. So we're going to talk about improving code quality and how we can get better. And the first law of programming says, lowering quality of code lengthens the development time. So if you really want to go slow in writing software, you really want to create a poor quality code. Then it becomes really hard and slow to create the code. So, but what is code quality? We need to be able to define what quality is. I'll tell you one definition I came across once. I used to work with a guy, he said, this code is really good because I wrote it. I don't think that's a good measure. We need to have a better way to define code quality. I'm going to say the quality of code we write is inversely proportional to the time and effort it takes to understand it. If you take more time and more effort to understand a piece of code, that's really poor quality. If the quality is really good, you will actually need less time and effort to understand it. So you can usually measure the quality of code by seeing how people are able to understand and accept it very quickly. So we're going to talk about 12 ways that can help us to get better at writing the code. So let's start with the very first one. I'm going to count down. And the first one is schedule time to lower technical debt. Now, this is not too highly technical at the code level, but we need to really think about the technical debt we accrue. So what is technical debt? Well, technical debt was coined by this gentleman, Ward Cunningham, and he coined it as part of his work when he worked in the financial industry. And he coined this term technical debt because technical debt is a lot like financial debt. And in the financial world, imagine I go charge a credit card. At the end of the month, the company says, oh, you have to pay me this minimum balance. And I'm like, this is interesting. I charge this much money, but I only have to pay this small amount. This is awesome. That means I can just spend more with the money I have at my hand. Let's say I continue to do this, and I keep spending more. And at one point, I exceed my credit limit. What happens when I exceed my credit limit? The credit card company sends me a letter, and they tell me that I've exceeded my credit limit. But you see, the credit card company cares about me a lot. So they don't want me to get into trouble. They want me to get into real trouble. So they increase my credit limit. Now I keep spending. And at some point I realize the amount I owe to the credit card company is more than my yearly salary. At this point, the only option I can think of is to change my name, grow a beard, and move to another state. Just for the sake of record, that's not the reason I left Texas. But the point really is that it becomes unsustainable at this point. It's exactly what happens to software projects. When you continuously trash the software project, the project gets to a point of technical bankruptcy. It becomes really hard to maintain software, and we can't continue with it. Nobody wants to work on the software anymore. And so in the long run, we should keep this in mind. But the question is, what are technical debt? Well, this particular API has changed quite a bit, but I haven't had a time to update to it. Oh, the schema has kind of gone out of bent. The requirements has changed over time. We kind of start patching up the schema, but maybe it's time for us to revisit that. In fact, the sad part is, You don't have to do anything to acquire technical debt. Your product is working, it's in production, everybody is happy. 6 months goes by, every single library you have been using, including the framework, has several new updates. You wait for a year longer, they tell you that the version your product is deployed on is no longer supported. You either move or you perish, right? And so you begin to acquire these kind of technical debt along the ways, and how do you really keep up with it? You have to make change, and you got to continue with it. But the problem is, we got to also keep in mind what technical debt is not. Writing poor quality code is not a technical debt. That's an intentional sabotage. We're destroying the product by writing poor quality code oftentimes. But when it comes to technical debt, we got to take the time to schedule time for paying these debt. It's not all or nothing proposition. Imagine a relative comes to you and says, I'm in debt. What's the first question you're going to ask? Give me the list of debts you have. And if they tell you, I don't even know what my debts are, that's a scary point to be in, right? And I go to a lot of different clients, and I would ask them, what are your technical debt? And I'll tell you, very few companies, very few teams have written down what their technical debt is. They all say, it's better it's unknown, right? It's left, why don't we write this down? Let's put it on the wall. Let's list it down, and so we can look at the list and see what those technical debts are, and then we can start addressing them one at a time. So start with the most expensive one, the one that troubles you the most, the one that's going to be the hardest to maintain. Well, the first step, of course, in identifying any problem is to realizing it, recognizing it. So ask your team to write down all the technical debts, list it down on a piece of paper, put it on the wall, and then you say, let's start scheduling time to pay the technical debt. Every sprint, we're going to give a certain amount of time, 10% time, 20% time. So we do schedule time for development, we all do. We also schedule time for other things. We got time on the schedule for planning. We got sprint planning, release planning, what have you, right? Then we have time for meetings. There's a stand-up meeting every day you guys do, right? There's a time scheduled for it. Well, then we also have scheduled time for vacation and sickness. Some companies don't give time for vacation. Then people take the time more in sickness. They kind of compensate for that, right? But the point really is, we're going to schedule these kinds of time. But one of the time we also have to schedule for is the time for paying technical debt. So you say in the sprint planning, we're going to say 10% of the time we're going to schedule for attacking these, and he's going to work in this sprint 10% of his time on paying this top level item. In the meantime, she's going to spend the time, 10%, solving the second item on the list, what have you, but everybody is working on paying technical debt along the way. But not only is technical debt important, there's something else that's extremely important. And I learned that from this remarkable lady, I admire her a lot, Linda Rising, and once she said, a freeway that's filled with cars is a parking lot. And that just resonated so much in my mind, because that's a wonderful metaphor. A freeway that's filled with parking lot. You know, one thing I've learned coming to Bangalore is the best time to travel in Bangalore is when the locals sleep. And they don't sleep too much, I found this out too. So 2 in the morning is a great time to travel because there's hardly anybody on the streets. But when you pack the streets with cars, what happens? It becomes a grinding halt, gridlock. This is exactly what happens to your projects, your schedule. When you fill your schedule with every minute where you have to do work, what happens? You have absolutely no time to change what you do because you don't have time to learn to improve. I saw a tweet which was absolutely phenomenal. The tweet said, what do you mean we have to fix the fence? We are so busy chasing the cattle. That's a beautiful metaphor. We are so busy chasing the cattle, we don't have the time to build the fence. I mean, if you build the fence, you don't have to chase the cattle. But we don't have time to build the fence because we're so busy chasing the cattle, right? Hey, why don't you write a test? Are you crazy? We don't have time to write tests. We got bugs to fix. This is what we do in projects, right? So, and this is something we need to keep in mind. And I came across this fantastic book, Guns, Germs, and Steel. And in this book, Jared Diamond says, there was a time when humans were savages. Good news, not many are savages today, but once upon a time, a lot of us were savages. And at that time, When you wake up in the morning, you have to go hunting. The day you don't go hunting is the day you starve. So you are always in chase of food. And if you don't go for hunting, you're going to starve. I better go for hunting. And as time went on, the savages eventually figured out they could actually do agriculture. This was one of the major milestones in human history. They started farming. They started growing crops. And when they grew the crops, they could store it. You can store the grains. What a novel idea. And then they found out they don't have to go hunting. You could domesticate animals. You could domesticate a lamb. You could play with the lamb. And when you're hungry, you can stab it and eat it. This is great. Well, wait a minute. You're going to have grains stored away. You're going to have lambs you can just eat. What are you going to do with your free time then? That's when art was born. That's when culture was born. That's when civilization was born. There's a very clear time history when the agricultural period and the period of culture and civilization are exactly the same. This is a lesson we can take home. If you are on the hunt every day, we are the savages in our companies. We don't have time to improve what we do. But instead, if we can automate, if we can get things going so we can spend less time, then we can spend time on finding other ways to improve. This is something I've taken to the heart myself. I'm a consultant. If I'm not at a client side, I'm not making money. But for the past few years, since I heard Linda say this, I started putting away a few weeks on my calendar where it says, this is my time. This is not your time. This is not for my client. This is Venkat's time. And during Venkat's time, Venkat is not going boating. I'm going to just sit and think. I'm going to think about what to do, how to do things. I'm going to do writing. I'm going to be exploring things. And what I do in the next year is greatly influenced by that one or 2 weeks I schedule for myself. But it doesn't have to be 1 or 2 weeks. When I used to work in companies as an employee, lunchtime is my time. They can come and tell me don't eat. And during lunchtime, I will reserve 15, 20 minutes, maybe 30 minutes. I always ate at my desk. I never went out for lunch because that's a lot of time wasted. When I'm eating at my desk, that's my time to explore things. I would read articles, I would read blogs, I would read whatever I wanted to read, or I would experiment. Or I would come to work very early in the morning before nobody is at work. That means there's nobody to bother you. This is a great time. And you can explore and read something before the crowd shows up, then you can do the real work. And as you do this, you can then schedule time to improve what you do. And so not only schedule time to pay technical debt, but schedule time for slack time as well. That's extremely important. The next thing I'm going to talk about is to favor high cohesion. Cohesion is where a code is narrow, focused, and does one thing and one thing well. When a code is narrow and focused, why do we care about it? Because it reduces the cost of change. That's what you really are after. So as you reduce the frequency and cost of change, your software becomes easier to maintain. So looking at every single piece of code, ask yourselves, what does it do? And it better do one thing and one thing really well. You can look at the cyclomatic complexity to understand this. The higher the cyclomatic complexity, lower the cohesion is. Higher the cohesion is, lower the cyclomatic complexity of code is. The next thing is to favor loose coupling. Well, coupling comes in different forms. Coupling is dependency. You cannot completely get rid of dependencies. So often we are told to loosen coupling. So we don't want tight coupling. We want to really reduce coupling because coupling makes it hard to extend the code, hard to test the code. So we want to minimize coupling as much as we can. So that's actually a good thing to do. But I'm actually going to go a little further and say, I'm not just interested in minimizing coupling. I want to go a little forward. I want to, as much as possible, remove coupling where possible, right? It's not easy all the time, but we should try. Let's talk about an example. Suppose we have something like this. You can see the code on the right, on the far left, depends on the code in the middle, the blue box of code. This depends on the one here, orange. Now, obviously, this dependency may be unpredictable. This dependency may be hard to work with. This may be giving you results that are really dynamic. Well, in that case, in order for me to write the test on this code, I have to almost mock every single test to mark the dependency. That means it increased the cost of your testing, made it really hard to test as well. But by moving things around, you could reduce your efforts. So I took the dependency I had here, and I moved it to the left all the way. Now, this code doesn't have the dependency, but wait a minute. A minute ago, it required one data coming in, but it went and got the other data it needs from this external resource. We're saying, no, don't do this. We're going to give you the two pieces of data you need so you don't have to go out and get anything. By doing so, we removed the dependency from this code, which means I don't need any marking at all for this code. I'll give it a fake data and get the work done. Sure, that moves the dependency, that makes this a little bit harder, but it had the difficulty already because it already had a dependency to deal with. By taking this approach, by moving dependencies around, we can actually make it easier to work with the system. So rather than trying to mark away dependencies all the time, spend some time asking the question, can I move the dependency so I can reduce the burden quite a bit? The next thing to think about is to program with intention. This is one of the biggest challenges for us. We program accidentally a lot. We write some code, and then we kind of wonder why it doesn't work. We write some code and say, what would happen if this changes? Or look at some code and say, can somebody explain why this code works? Opinions are so beautiful. 5 people will tell you 5 different reasons why this code is working. But if we write the code with intention, it looks different. I came across this gem, and I think most of us can agree to this very quickly. And this gem is this. It says, when I wrote this code, only God and I understood what I was doing. Now God only knows. How many of us feel this way most of the time, right? Especially after a vacation, right? What is this code doing? The other day I saw a guy who was very angry at a piece of code. He was yelling and screaming. What idiot wrote this? After 20 minutes he realized that was me 5 months ago. He's not complaining anymore, right? So it feels like that a lot of times. It's a code that we don't understand, we can't maintain. Well, Ken Beck has some really good recommendations. He's got this so-called 4 rules of simple design. He says the very first rule is that the code passes all the tests. There is an implicit assumption there. We got tests. So the code passes all the tests. The second rule, and he says this in the order of decreasing priority. And the second rule he says is the code reveals intention. You should be able to look at the code and immediately say, what does the code mean? What does it convey? It should be expressive, right? It should have the intention very quickly. The third thing he says is we should remove duplication as much as we can. But notice, you don't remove duplication by compromising intention. If the intention is clear, then remove the duplication. That's what he says. One of my favorite is the 4th one, minimalism or parsimony, having the fewest number of elements. Fewer classes, fewer lines of code, fewer components, fewer dependencies. And that's a really good thing to follow as much as we can. We can get better in writing code by following this thing called Ken Beck's rule of simple design. All that you have to do is Google for those words, rule of simple design, and you'll find it. So we want to program very deliberately. But one way to program with intention is to write tests before we write the code. If you write tests before you write the code, you are thinking about the usage of this code before you even write it. The code becomes a lot more expressive doing so. The next one is one of my favorites. Avoid primitive obsession. This is one of the biggest challenges we deal with. As programmers, we feel we have to write every single thing. The other day I was code reviewing. I saw this code, which was about 30 lines of code. I read it and I reread it and I reread it. Something bothered me. And that's when I realized this 30 lines of code was doing what was already done in the JDK with one function. And all I did was, I didn't say anything during code review. We had automated test passing, the tests are passing. All I did was, I quietly commented out the 30 lines of code. I wrote that one line of the JDK call. All the tests still passed, and I quietly checked in the code, didn't say a word. But an hour goes by, I saw the version control show that the file has been updated one more time. I was curious, I brought the file over. Apparently the developer who wrote the code in the first place saw what I did and realized how silly it was to write these 30 lines, removed the commented code and checked it in, that's it. That's a really nice way to help people to learn as well. We don't have to go lecture to them. Just do the right thing. People are smart enough to figure out and learn along the way. They say best way to teach people is just do it rather than telling them to do, right? That becomes a lot easier. I'm going to say imperative code is packed with complexity. There are two kinds of complexity we have to deal with: inherent complexity and accidental complexity. Inherent complexity is the complexity of the problem domain. We all can agree eating a pack of peanuts is a lot simpler than doing brain surgery. There's very clear distinctions here. But you can also make it really hard to eat the peanuts also, right? So the point really is, you can think of the complexity brought by solution versus complexity brought by the problem itself. But let's talk about this real quick with a little example to see what this really means. Why would it be more complex than others? So let's take a look at this example. I got a function called is prime. Don't worry about how it works. It tells you whether the number is prime or not. That's all it's doing. Now I have this function. And this says, given n and k, some random number n and k, it calls a method called compute. What am I supposed to do in the compute? The compute says, find the total of the square root of the first k prime numbers starting with n. We should be able to write this code very easily, right? So find the total of the square root of k prime numbers. Aha, starting with n. So int index equal to n. That's a good start. Int count is equal to 0. That's a good start. Double result is equal to 0. That's also a good start. And when we are done, we're going to return the result. That's a good start too. What did we do so far? Absolutely nothing useful. All we did was defined a bunch of variables. What's our next step after this? While count is less than k, what do you do immediately? Ask the question, is it less than or equal to? Do you ever ask that question? Every single day. And you say it's less than, and then you pause and say, really? You want to go to the restroom, but you take a few steps, you think, is less than or equal to? You're never sure, right? And then you're talking to a colleague, and you're like, wait, did I put less than or equal to? You're eating food. Your family says, are you okay? Yeah, I'm fine. Are you really okay? I'm fine. You look very pensive. No, I'm really fine. I just don't know if it's less than or equal to, right? This is bothering us all the time. How does it make you feel? It makes you feel stupid. And then what do? Then you say, okay, if is prime of index, if it is a prime, what do? Result is equal to, plus equal to math dot square root, so math dot square root of index. And then you return the result. Is this done? Speak up. Is it done? No. What am I missing? I have to what? Increment the index? You want me to increment the index? Okay, fine, I'll increment the index. So index plus plus, I will increment it for you. So right there, index incremented. Is it done now? What am I missing? Increment the count. Count plus plus. Is it done now? What did I miss wrong? It should be outside. Sorry, thank you. It's outside now. Is it done? It should be inside. You just said it should be outside. Oh, the count should be inside, index should be outside. How do you feel about this? Is it correct now? Did you notice? You went from it's broken to I am thinking. I'll tell you one thing. Programmers are the smartest people on planet Earth. Because you show this code to them and say, is it correct? You know what they'll tell you? It looks good. They never tell you it's correct. Because you know what's going to happen? When they find this is busted, you say it only looked good. Right? So you never admit it. So you put hope in it and say, I hope this is correct. And then you can take the faith and run it. And then you say, I'm going to run this and see what it does. Oh, it gives you 77034. How many of you have written code like this one before? Everyone has done it, right? How do you feel about this? I got this theory. It's the code like this that prematurely turns programmers into managers. Right? They're like, that's enough. I'll leave this to you clowns. I've got better things to do, right? And not many people can deal with this kind of stuff, right? They go crazy over it and like, this is not for me. And people come to me, I once did the programming. Of course, I can realize why, right? They're no longer surviving in this. So this is really hard, isn't it? But we don't have to go through this. Is the problem a hard problem? No, but the solution is very hard. That's an example of accidental complexity. Accidental complexity is where we take a simple problem and totally mess it up, right? But we don't have to do it. Let's try this again. What are we going to do? Well, let's do this in the most fundamental functional style. So comment that out. Try this again. I'm going to start, first of all, saying return stream.iterate. And I'm going to start with a stream.iterate, starting with what? N. Given e plus 1. What in the world is this? That's an infinite stream. Oh my gosh. What's the size of an infinite stream? Dude, it's infinite. It starts with n plus 1, n plus 2, n plus 3, n plus 4, n plus 5. Okay, we got to stop it. It keeps on going. I know what you're thinking. If it's infinite, where would you store it? On the cloud, of course. The point really is, it's an infinite stream, right? Some people actually took that seriously. They're writing it down. This is awesome. I love cloud computing. I just made a joke. Okay. I don't want somebody to say, this is awesome. Cloud is awesome. No, just kidding. Okay. So the point really is, it's infinite stream. But then I'm going to say, all right, got it. Then filter. Sample is prime. I'm calling the is prime method. Map, math, : square root. Well, then what? I found only the prime numbers. I got only the square root of those. What am I going to do? Limit k. Hey, is it less than k? No. Is it less than or equal to k? It's k, damn it, keep moving. And then, of course, you're going to do a sum operation on it. Produces the same result. Look at the complexity or the lack thereof. The code begins to read like the problem statement. Given all the numbers starting with n, give me only the prime numbers, give me the square root of them, but only k of them, and total it. Look at the code in the top. Imagine looking at this code in the top. In the meantime, your business analyst comes to you and says, hey, what's this code doing? You look at the top code and say, that's what I'm trying to figure out. You be quiet now, right? But in the code in the bottom, you can actually have a conversation with them. And you can say, that's what I'm doing. Does it match with your needs? So this code removes the accidental complexity from it, as you can see, so we can use the functional style. A good code should read like a story, not like a puzzle. The code in the top was like a puzzle. You're trying to say, let me figure it out. And you're writing a puzzle. What happens when you write a puzzle? Your other colleagues are spending the week figuring it out. And then there's a scream in the room. That's when you know they got it finally. You think your colleagues are going to be quiet when they discover the puzzle? They're going to write the next puzzle for you to solve. In the meantime, we got a production code to release, right? So a good code should read like a story, not like a puzzle. Well, it turns out the imperative style of programming is where we say how to do, and the declarative style we say what to do. And of course, functional style fits into it really nicely. So we were moving towards functional style because it has less complexity than imperative style of code. That's why we're moving in this direction. Prefer clear code over clever code. Honestly, how many of you have ever written clever code? At least at some point of the time. Is that it? Come on, be honest with me. Everyone has. How do you know you've written a clever code? You write a piece of code, and the minute you write it, that proverbial hand comes and pats you in the back and says, you are awesome. And you're like, oh, that feels good. Have you ever felt that? We all have. That's a sign you have written a clever code. I'll tell you my story. I had a client of mine email and said, we have a problem, we need to fix it. I looked at it, 10 minutes I can fix it. But no, I don't want to fix it. I want to fix the mother of all problems. I will write it in such a way, not only will this problem be solved, I will prevent all such problems in the future. And so it took me an hour, and I came up with a very, very clever solution. And the minute I wrote it, I had an out-of-body experience. Literally, Venkat got up, went around, and hugged me and said, you are the most awesome. Like, this is great, I'm clever. And I checked in the code. About 3 weeks went by. I got an email from the client saying something absolutely terrible has happened in production. I looked at it, responded, said, I can fix it. They said, I know we can, we know you'll fix it because you are that smart. I said, no. I'm going to fix it not because I'm smart. I'm going to fix it because I caused it. And then what did I do? I rolled back my code and put back the 10-minute change. And I checked it in. No problem in 6 years. I've learned a lot from that. Nowadays, I write code. And the minute I write code, I tell myself, that's a clever code. I delete it right away. And I start over. I want to write clear code, not clever code. So that is something we should really try. Beautiful quote here. Programs must be written for people to read, and only incidentally for machines to execute. So we are optimizing code for writability. We should be optimizing code for readability. That is the most important thing we should really aim for, because if nobody can read the code, what's the point in writing it? So that is something we need to really think about. I'm going to say 10% of the time we write ugly code for performance reasons. The other 90% of the time we write ugly code just to be consistent with the other 10%. So anytime people tell you this, I had a colleague come to me last week and said, I want your opinion, Venkat. I said, what opinion do you want? I have this other colleague, his code is horrible. I can't understand it. But he tells me he has to write it this way because it gives better performance. I said, before I answer, let me ask you the question. Has it given you better performance? He said, no. So what's the problem now? But we can't even change it anymore because it's that ugly. And that's the whole point. Those who sacrifice quality may end up getting neither the quality nor the performance. And the code becomes really hard to maintain after a while. So we need to be very careful how we write code. Make it better, make it work, make it better real soon. Let it be easy to read, easy to understand, then come back to improve the performance. A beautiful quote by Tony Herb. He says, there are two ways of constructing a software design. One way is to construct it in a way that there are no deficiencies, obviously. Or you can write it so complicated that there are no obvious deficiencies. And we have to decide. Sometimes the code is so convoluted you don't even know in what ways it's broken. The next principle I want to talk about here is called the Zinzer's principle. This was one of my aha moments. Usually we learn technical stuff from technical books. I came across this. I got a copy of this wonderful book. It's a 30-year-old book. It's a book on writing good English, writing non-fiction. I highly recommend this book. It's called On Writing Well. William Zinzer passed away a few years ago, but he left a wealth for the world. As I was reading this book, he teaches how to write better English, how to write better non-fiction. But as I was reading this book, I told myself, oh my gosh, what he says is not about writing English. I can apply this to writing code. In fact, I liked this book so much, I was mentioning this book to my son who was 10 years old at the time. He said, Daddy, you keep talking about this book. I've heard you say this book so many times. He said, yep, I love this book. He said, can I have that book? No, it's my book. So I got him his own copy, which is a good thing. And since then, he's been reading this book every summer. And he told me, Dad, this is not a book to be read. This is a book to be reread. And I know he's reading every summer. You know how? Because we would be reading something together, and he would suddenly say, oh, wait, look at this sentence. And then he will quote something from William Zinzer's book. He would say, this is what Zinzer says, and look at this sentence, it follows that, or it doesn't. But he would give me very concrete examples from this book. Since I saw him learn so much, I've made it a mission in my life. Now I travel around the world. I'm in random cities around the world oftentimes. And one of my friends would know that I'm in town, and they would invite me for dinner. And the minute they invite me for dinner, I would know they have young children. So on the way to their house, now I've made it a mission, I go get this book from the store. And when I go to their house, I say, here's a book I really like. My children have read this. You should read it. And the next time Uncle Venkat comes to your house, he's going to ask questions from this. Children get scared. They never invite me again. But the point really is, this is a fantastic book. In this book, Zinzer talks about a lot of things, but he outlines 4 principles for writing good English. The first principle, he says simplicity. Who agrees that simplicity is a very important principle of programming? Absolutely, right? That's what we do when we write code. Keep it simple, keep it simple, keep it simple. If you write something really complex, nobody understands it. Why don't things be simple? When a code is not cohesive, it is not simple, it's complicated. So we want to make things really simple. He says, improve the clarity of your writing when you write English. Well, we also strive for clarity in code. What makes code non-clear? Excessive mutability makes it really hard to understand the code. How many times have you looked at a piece of code and it's changing a lot of variables? You're trying to struggle. Which variable am I changing now? What is the current state of the variable? Mutability reduces clarity. Coupling reduces clarity of the code. The next principle he talks about is brevity. He says keep things short. He says shorter sentences are better than longer sentences. Shorter paragraphs better than longer paragraphs. Shorter chapters better than longer chapters. Shorter books better than longer books. Same thing writing code. Shorter functions are better than longer functions. Shorter classes better than longer classes. Shorter components better than longer components. So we want to really aim towards brevity. He says one thing in the book. He says, when you speak to people, don't say, how may I assist you? He says, say, how may I help you? The word help is so simple than the word assist. Now this brings back a very fond memory. Decades ago, I really wanted to go get education in the US. So I started preparing for the GRE exam and the TOEFL exam, all those exams. And I was very poor in English. I could not speak English until I was 17 years old. I couldn't put a word or sentence together. And I had to read English. And I tried, and I tried, and I tried. I couldn't get back the alphabet in the A list, leave alone the rest of the alphabets you have to, list of the words you have to memorize. I struggled really hard. And then I came to a very bold conclusion. And I said to myself, forget this. I will never be able to pass English. So I worked really hard on where my strengths were. I worked hard on math and analytical. I got almost top scores in math and analytical, and I failed English. And I still applied. A university took pity and said, this guy cannot speak, but he can, solve equations. Bring him on board. Just don't talk to him, just give him equations. And I went there to the US with this. And then I realized something absolutely phenomenal. In the last 30 years, no one ever came to me and used a single word from the damn GRE book. I understand what people say. You know what I tell people there? Forget about building walls. The GRE book is already doing for people like me, trying to keep me away. But the point really is, people speak in a way you can understand. I don't have to say, could you please hold the thought for me? Use the word, I'm going to look in the dictionary right now. No, people speak words it's easy to understand. And that's the whole idea. Speak in a way people can understand you. Well, the last principle he says is the one that I had the most difficulty. Humanity. Gosh, humanity. We write code for the machine to execute. And then I realized this is one of the most important principles. Because we don't write code for the machine to execute, we write code for other people to read. And we create this illusion around us. The other day, my optometrist was looking at my eyes. And she said, what do you do for a living? I said, I'm a programmer. And then she went on to do other things. About 5 minutes later, she said, what do you do for a living? I said, I'm sorry, I told you that I'm a programmer. She said, yes, I heard you the first time. I just wanted to ask you again because you look almost normal. Right? And we have given this impression, somehow if programmers, we shouldn't be normal. Right? And humanity is extremely important for us to have. The next principle I want to talk about is comment why and not what. This is something that really irritates me. People write comments when they shouldn't be writing comments. It's really ridiculous if you really think about it. The other day I was looking at a piece of code and the programmer had written I++ and a very helpful comment, increment. I'm like, thank you very much. I'm getting older. I'm not able to see properly anymore. My glass power has been increasing. So I looked at it, I was not sure. So this is very helpful. This is telling us what the code is doing. But the most important question is, why? Why are you incrementing right here? Or something else which is so beautiful. It would say I and then 2 and then a very friendly shift. Why are you shifting? Why in this place? So we tend to really write comments which are not helping at all. But what should we really be commenting? We should really be commenting why the code exists. Why is there? What's the purpose of this code? And this is something that's very near and dear to me. Don't comment to cover up bad code. If a code is not clear, don't say, I don't understand this comment, time out. I don't understand it. Refactor it. That's the opportunity for refactoring code to make it easy to read. Write expressive code which is self-documenting. My mind is broken. I think of programming all the time. Any minute I'm awake, I'm always thinking about programming. So I was in Washington, D.C., and I wanted to take a shower. I got in the shower, and I saw something which was really annoying. Well, I'll come to that in a second. I'm going to say a good code is like a good joke. What about jokes? You say a joke. People laugh. You say a joke. Nobody laughs. The worst thing you ever do at that moment is starting to explain the joke. It never goes well. You say a joke, everybody's like, huh? Let me explain it. And then you take the time to explain it. Then they say, so what's funny about it? No, let me re-explain it to you. This is called a very long evening. When you say a joke and people don't get it, there's only one right response. Never mind. Never mind. Just forget. I didn't even say it. Then you go home that night, sit down quietly, and you refactor your joke. And then try it with a different group the next day and see how it goes. It might work. If it doesn't work, joke is not your profession. Don't go there. So the point really is, a good code is like a good joke. Just lay it down and walk away. Don't try to explain it. Writing comment to explain what a code is doing is like explaining a bad joke. Don't do that. So I was telling you about getting into the shower in Washington, D.C. And I got so angry when I saw this. We live in a world today, when you're angry, you don't shower. You get out of the shower and you tweet. That's what I immediately did. I saw this and I got so angry. I got out of the shower and I got my phone, took a photo, and I had to tweet it. And my tweet said simply this: those who cannot design are condemned to document. I looked at the damn fools. You gotta tell me pull to turn. Why can't you make it easy so I will do whatever it is to shower? And I feel insulted because I'm in the shower and you're giving me a documentation to tell me how to use the shower. The other day I want to take a tablet. I had cold. So I took the cold medicine. And the label says, take 2 tablets every 4 hours by mouth. What else are you thinking? I feel insulted every time somebody's got to tell me how to do stuff. Why can't we just be intelligent? Why don't you make it intuitive so I can understand it? Int P1, int P2, int P3. Dot, the IntelliSense gives you. This function takes you 3 integers, int, int, int. Why me? What did I do to you? Why can't you tell me what those ints are? We told you, P1, P2, P3. What's wrong? I'm not clear about it. Order 3. Order what? 3. 3 what? Oh, sorry. Is it cups of? No, it's large. Large coffee. Write a comment on it. Or what about an enum? Maybe that becomes expressive. So don't document to cover up bad code. Explain why, not how. Explain why, not what. Avoid long methods. Apply the slap principle. Long methods are evil. The more long methods we write, the harder it is to maintain software. And it's all not about the length of the method alone. It is actually the levels of abstraction the method should have. It turns out we need to really keep an eye on the levels of abstraction. Give good, meaningful names. They say one of the most difficult things for a programmer to ever do is give names for variables. I have found out what a programmer really is over the years. A programmer, one who can name their children quite easily, but has a hard time naming their variables. My wonderful wife came to me and said, "Sweetie, I'm so delighted we're going to have a child." I said, "I'm very happy too. We need to pick a name for the child." "Oh, I've already picked." "Seriously?" "Absolutely, here's the name." That quickly, "Yes." "Do you want to reconsider?" "No." "Any other names?" "No, this is the name for our child." Now, if you will go do other things, I've got to think for variables, but names for the variables. It's really hard for us, right, to think of abstraction. What do we give? Well, normally, if you don't know how to give a name for a variable, it usually means we haven't understood the abstraction. I was at a client site. As I was doing code reviews and working with them, they showed me a code and they kind of moved away. I said, whoa, 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 can you go back to that window? And he did. I said, I know we have NDAs and all that, but I will be very careful. But would you allow me to take a photo of just this screen? He said, yeah, go ahead. So I took a photo of it. And that's what you're seeing here. You may say, yeah, so what's the big deal? Oh, I'm sorry. That's not what I wanted to show you. What I really wanted to show you was what was below this. This is my real production code. And these are the programmers trying to maintain this code. Sometimes I feel these programmers are like cave people. You are in an expedition, you go down a cave, you go through the rope, and you land, and then you find writings on the wall. And you try to translate it. And it says, help. And then look down, there's bones. Those were the last words of these people, right? Screaming for help. That's how I feel about programmers. They're looking at this code. I live in Colorado. And in Colorado, there is something called a cave dwelling. Literally, people lived in these caves. So I go up the mountains, and I'm looking at this cave one day, and they have these artifacts, beautiful Stone Age stuff and other things they've displayed. And I was kind of enjoying it. But next to it on the wall, they said something, and the minute I read it, I screamed. What it said was, these artifacts had a meaning once upon a time, but the meaning was lost forever. And I said, this is exactly what I do at work. This code had meaning to the guy who wrote it. And now that the guy has left, the meaning is lost forever. So I decided my title is no longer a software developer. I'm a software archaeologist. Because I go to work every day and try to discover what the heck did this code do before. That's how we feel about it. Because variable names represent abstraction. And we cannot ignore those abstractions. If we cannot name a variable properly or a function appropriately, then it simply means that we haven't understood its true purpose. And it's very hard to name the variables very quickly. We have to really take the time to reiterate and name things. Do tactical code reviews. I want to emphasize, I'm a huge fan of code reviews. But I will say when I talk about code reviews, I'm not talking about traditional code review a lot of people do. You stand up one day and say, we're going to do code review. And the minute you say this, there are three things that happen. Well, Joe, whose code is going to be reviewed, says, forget it, I'm going to call in sick. I don't want everybody to bash me on the day of code review. Sarah says, look, I'm already behind schedule. I don't want to look at the stinking code this Joe wrote. In the meantime, the boss says, tell me this again. What is this thing called code review? Oh, is it the thing like the last month on the Thursday afternoon? You had everybody from the team in this room, and you projected the code on the screen, and you critiqued it. Oh, yeah. Heck no. Because the last time you did this, we had a fight. We had to call the cops, and 2 people quit. No more code review for you, right? So code reviews are very, very political. Nobody likes it. But we do code reviews all the time. But the way we do code reviews is very tactical. That's why I call it tactical code review. Well, code reviews are very significant. They can reduce bugs, error rate in code a lot. In fact, code reviews complement automated testing quite a bit. But the way we do code reviews is what I call as a tactical code review. So I have written a piece of code. Oh, by the way, the first rule, there is nobody on the team who is beyond code review. Nobody is too senior to be code reviewed. Everybody's code gets reviewed. I write a piece of code. What happens? She reviews my code this time. The next time I write a piece of code, he reviews it. In the meantime, the code she wrote, I could be reviewing or you could be reviewing. So one person reviews the code while the other person finishes writing it, and we rotate the reviewers over time. One other thing we don't follow. In some companies, they take this and say, aha, this is important. So you will not check in code if it's not reviewed. And guess what happens in those companies? They don't check in code because it's not reviewed. And then one day, somebody says, I got stuff to release. And I'm going to say, I'm waiting for code review. Have you reviewed my code? He's like, no, I have other things to do. Like what? Writing more code. And what did you do with the more code you write? It's here. Why don't you check it in? Because somebody else has to review it. What about them? They are busy writing their code, right? Then I come to him and say, do me a favor, please. Just review the damn code now. Because I got to check in. Looks good. And then we check it in, right? It makes no sense. You cannot put process to improve people. You can improve people only by motivation. If I feel this is useful, you cannot stop me from doing it. If you threaten me, if you put process around me, I will find a way to beat it. So the only way to influence change is to motivate people. When you feel it right here and say, my gosh, this is going to make my life better, I'm going to go do it, right? So that is why the tactical code review, when everyone on the team benefits from each other. Second thing, remember, you are not reviewing code. It's very emotional. Never say anything negative. I shouldn't take his code and say, this code sucks. Or, where did you learn writing code anyways? Right? Those are really bad things to say. My recommendation is always suggest a change, not what's wrong. I'm looking at a long method. Here's what I don't want to say. Long methods are awful, don't you know? Instead, hey, I see this method. It does what it's supposed to do. That's awesome. But do you think we could break this into these 3 methods, focused on this abstraction? Now the beauty of this is you give them one option. And I always tell my team, I'm going to make a suggestion. You have 2 options. Either do what I say or do better than what I say. Right? So you're always giving one answer. You could do this. Hey, but what about this? Even better. Thanks for suggesting. You don't have to do what I say. You can do something better than that. But that's important. The last thing I will tell you is to reduce state and state mutation. We have been increasing state so much. If you ask me, what is it that you do, Venkat, today that you're doing very different than you did 10 years ago? I'll tell you what I'm doing today different from what I did 10 years ago. 10 years ago, when I wrote my object-oriented code, I bloated my objects with state. I wrote big objects, a lot of fields. Now I code review a lot of developers' work. The very first thing I noticed them do is they create a class, private field, without any other thing. It's a foregone conclusion I need to have this field. I would help them refactor the code. We would either not have any field in this class at all, or we'll have very little. We've been writing code with way too much state than we actually need. I'm not saying eliminate state, that's not the word there. Reduce state as much as you can. And also reduce state mutation. We have learned some of these things. Mutability is not something we should really encourage. So my recommendation is think more, type less, aim for minimalism, fewer states, less mutability, and just enough code for known relevant parts of the problem. The more we pollute the code, the harder it is to maintain it. Messing with state is the root of many problems, both in software and in politics. This is why governments fight with each other, right? They're messing with somebody else's state all the time. I don't have to tell you that you know this already, right? We see this all the time. Oh, I want a different state. Like, why? Just leave the state alone. Don't mess with the state. Mutability needs company. It often hangs around with bugs. The more mutability in your code, the harder it is to maintain it. The more errors we have to deal with as well. So as much as possible, reduce the state. So we talked about 12 ways to make the code suck less. I want to leave some parting thoughts with you. Writing code is a lot of fun. I am a programmer today mainly because it's fun. When I started programming because it was a career. And then came a point when I realized I'm no longer programming because I have to. I'm programming because I want to. And that's a beautiful state to be in. Because doing what you want, like leaving the room, is a lot better than having to do something, right? And that is something to think about. And when you want to do it, and the reason I program today is, being a programmer is like being a kid in a candy store every single day. I don't feel old at all when I program. It's like the very first day I started programming. You are constantly exploring, trying to figure things out. How would this work? And it's very enriching experience. And I cannot imagine the day that I don't have to write code. It's a lovely experience. I showed you 12 different ways. I talked about scheduled time to lower technical debt, favor high cohesion, and favor loose coupling. Program with intention. Avoid primitive obsession. Prefer clear code than clever code. Apply the Zinzer's principle. Comment why and not what. Avoid long methods. Follow the SLAT principle. Give meaningful names of variables. Do tactical code reviews. And reduce state and state mutation. But there's one thing that I will say. When we work as programmers, we have this constant pressure. Have you done? And people say, I've written the code, I'm making it compile right now. It's crazy. At some point, we begin to realize, maybe we're doing this wrong. And if there's one thought I can leave with you today, it will be this thought. The first step in becoming a better programmer is to let go of this conviction that we can code it once and get it right the first right. Because we don't write software. We rewrite software. Thanks for your time.